Hello there. In this video we're going to discuss how to solve basic cubic equations. Now you can give this problem to your friends on social media. For example, if x cubed is equal to 8, what is x equal to? Most of them probably will say that x is equal to 2. If they only say 2, they are wrong. Because as we know, the fundamental theorem of fundamental theorem of algebra, states that there are three solutions to this equation. Perhaps all of them are the same, but in this case, all of them are different. So we're going to explore how to find all of the solutions to basic cubic equations. Alright, so as we mentioned already, the fundamental theorem of algebra states that there exist three solutions to this equation. And it's easy to verify that 2 is definitely one of them. No problem there, right? So what I'm going to do is define the following. So I'm going to take f of x and I'm going to define it to be equal to x cubed minus 8. So I'm subtracting both sides of this equation. So we can easily verify that f of 2 is equal to 0. So as we already know, if that is true, then that means x minus 2 is a factor of our function f. So now we can use long division or synthetic division, whatever you prefer. I'm going to go with long division. So we're going to divide x minus 2 into this cubic, right? So x cubed plus 0x squared plus 0x minus 8, right? And we're going to see what the resultant is, or the quotient, right? So x times x squared is going to be x cubed, and then I'm going to multiply that down. So x cubed minus 2x squared, and then subtract. So that's going to be 0 by design, and then we're going to have 2x squared here. X times 2x is going to give us 2x squared. 2x times x is going to be 2x squared. 2x times minus 2 is going to be minus 4x, and then I'm going to subtract everything down, right? And then we're going to have what? So then we're going to have 0 minus negative 4 is going to be 4x, and then we're going to have minus 8. X times what gives us 4x? Well, we know that's just going to be 4. And 4 times x is 4x, and 4 times minus 2 is minus 8. So we should get a remainder of 0 because we know x minus 2 goes into this evenly, right? And here's our quotient. So that means what? So that means f of x, which is x cubed minus 8, can be factored into x minus 2 times, what was that? X squared plus 2x plus 4, right? So now we have a monomial, a linear monomial, and a quadratic. So now we can find the other two by setting this thing equal to 0 and solving that quadratic, right? So quadratic formula says x is going to be equal to negative 2 plus or minus the square root of b squared minus 4ac all over 2 times a. So that's of course equal to minus 2 plus or minus 2 times the square root of 1 minus 4 all over 2, which is the same thing as negative 1 plus or minus the square root of 3i, if you're familiar with complex numbers. So now we have our answers. So if somebody says, okay, x cubed is equal to 8, what is x equal to? The correct answer is x1 is equal to 2, x2 is equal to negative 1 minus root 3i, and x3 is equal to negative 1 plus root 3i. So these are the three solutions. So let's do another very related example. Suppose we have g of x is equal to x cubed plus 8. So you should know a trivial solution, namely negative 2. So g of negative 2 is equal to 0. That means x plus 2 is a factor. So take a moment, do long division, and see what that quotient will be equal to once you divide x plus 2 into x cubed plus 8. Once you do synthetic or long division, you'll realize that this factors into x plus 2 times x squared minus 2x plus 4. Almost the same exact thing, but this middle sign is a minus sign. So using the quadratic formula on this expression, you can find the zeros of this. So that means x must be equal to minus 2, 1 plus root 3i, and 1 minus root 3i. For the other one, it was negative 1 plus and negative 1 minus. So almost the same solution, but not quite different. And these are, again, the solutions to the equation x cubed is equal to 8. Right? X cubed is equal to negative 8. Now, of course, I'm just choosing 8 because it's a very easy number, but you can actually extend this to pretty much any cube of a real number. And then you'll get these properties. Namely, a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared, and a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. You can FOIL the right-hand side into the left in order to verify these if you want. So some people refer to these as the sum difference of cubes formula. And the only differences between them, plus goes to minus, minus goes to plus, right? So that's pretty much the relationship. The last sign, always a plus. Alright, so let's consider a particular form so we can understand the types of solutions that we may have with this. So suppose we have, as an example, x cubed is equal to a cubed, right? So if this is the case, then that means we have a cubed minus a cubed is equal to 0. So I can use my difference of cubes relationship, so that's going to be x minus a times x squared plus ax plus a squared, right, is equal to 0. So I clearly have one solution, right? So x1 is equal to a, that's obvious. So what are my other two solutions? Are they always complex, or sometimes are they real? So x2 and 3 are going to be equal to negative a plus or minus the square root of a squared minus 4ac all over 2a. We can factor out an a squared here, so we have that x2 and 3 are going to be equal to negative a plus or minus a times the square root of 1 minus 4 all over 2. So therefore, x2 and 3 are going to be equal to minus a plus or minus a square root of 3i all over 2. So it's very important to notice, that is a 2 of course, that this expression always lies in the complex plane, right? And that's for all values a in the set of real numbers. So it's always true that if you have an equation x cubed is equal to a, or x cubed is equal to minus a, these two equation structures always have the same exact type of solutions. In particular, we're going to have one real solution and two complex solutions. And it should be very easy to see from the graphs of these curves that this is true. For example, if you have y is equal to x cubed minus a versus y is equal to x cubed plus a, these are just vertical shifts of your curve, right? So that's one, that's the other, right? So this is a. Notice one real solution, that means the other two must be complex. Anyway, this is just an introduction on how to solve basic cubic equations. Hope you enjoyed.